Hello everyone, and welcome to the Introduction to Data Science and its Process, given by M.Mahdi Fayazbakhsh. I am Wedad Anbtawi, the organizer of this workshop on behalf of FruitPunch AI and YADS. Before starting, I hope all the Lebanese people who are attending are okay and their families are safe. And our hearts are with you. So, Mahdi, you can start.
A very short introduction about data science. We focus on what is data science and who is data scientist. And I would also then show a case study that what are the steps to do a data science project? What are the necessary and basic steps that you need to take care of them to do a data science project. Very briefly, introduction about my background, that I study bachelor and master in statistics in Tehran in Iran. I'm originally from Iran. I moved to Spain. I did another master degree in big data analytics, and then I moved to Netherlands in Eindhoven. I did a professional doctorate in data science, and just 6-7 months back, I joined Omron as an R&D engineering and data scientist. When you search for what is data science or who is data scientist, you see a lot of these figures in the Google. I just got a screenshot of my search. And you see that, yeah, there are many knowledges you need to learn, many different backgrounds people have, mathematics, statistics, computer science, different programming language knowledge you need to know, skills you need to know, the non-technical skills, technical skills you need to know, a lot of things. So at the beginning, it's kind of, when you look at it, it's kind of shocking. And you think that, yeah, that's something that you cannot achieve. And basically, there is people saying that the data scientists are unicorn, and this is something unique, and you cannot be, or if you are very unique, and you are a very special person. But I don't believe it. I don't think that you need to be a unicorn to be a data scientist. And none of the data scientists are very unique, and can you call them a unicorn? Yeah, basically, I haven't seen any data scientist that is like as beautiful as this unicorn, and also very unique as this unicorn. So what is exactly data science? I personally like to have a very simple definition for everything. It's helped me to understand what's going on in that field or in that domain. I like to have the very simple definition at the beginning of studying everything. So data science, first of all, is not a field. It's a field. It's not a science. So there are many science are involved, but itself, it's not a science. This is my definition of data science, which is people collaboration around data to solve a problem. And by using this definition, data scientist is a person who can solve a problem. So problem solver who solve problems using data. So very simple definition. I don't talk about the technical things, knowledge you need, nothing, just problems. Our world is full of problems, just problems, and then you solve those problems with data. I give you an example about what happened in one project 2 years back for me. So I was involved in a project. That's a funny story. I was involved in a project that was about making an app, a tool that helped to help people in one city to manage and optimize their energy consumption. And during doing that project, we had a meeting with a very, very old lady. She was, I think, more than 70, 75 years old. And she was living in that city for her life. She had a lot of data about neighborhood, about people lifestyle, about the city itself, about the events that are in the city every year. Many data she had, and she transferred all of those data she had as an information to us. And she helped us a lot. And after that, based on discussion with her, we could create an app that people, neighborhood people, residents could use that app to optimize their energy and see how they are using energy and how are different from their neighbors and how much they are different from their city and so on. So I call her, I'm telling you this story because I call her that a person who was in our team. So she was kind of data scientist. So she had a lot of data. She transferred all of those data, analyzed those data, and transferred all of those data as an information to us without having any background of mathematics or statistics or whatever. So anyone can be a data scientist. This is my definition. Many people maybe are disagree, but anyone can be a data scientist because we have problems and we are happy to use data to solve those problems. So please, you are also welcome. If you are not already a data scientist, you are curious about joining the data science area, yes, you are very welcome and please join. But it is not always that simple with this definition. That's why I want to explain one of the graphs that you might find in internet. Briefly, I want to show that how you can see this image and how you have to proceed for data science project. So here you see the start, and at the beginning of the start, you see the business understanding. It is the most important part of each project of data science, that you understand the business behind and understand what the end user wants. Without understanding what you're doing, whatever you do is useless, and nobody is going to use it. So this is, I'm saying, please, please understand what you do. Please understand the business you are involved. And this is the key point of starting a data science project. And after that, when you understand the business, so you need to, you have the question, so you need to have a data. So in data part, data acquisition and understanding, you need knowledge for data sources, pipeline you need to make, APIs, how you make an API, the environment your data is there, you have data in the SQL database, or you have in the cloud, you have in Azure or AWS, these cloud services, or you have it locally in your server. So kind of IT, or other people call it data engineering. So those knowledge you need to know so about the data. And also what it is very important in each data science project, you need to know about data cleaning part, which is very important. And it is the root of your modeling, which is on the left side. So in general, data acquisition and data understanding, you need different knowledge, different, it is people from computer science part, people with data engineering background, they are very good in that part and they are very successful in that part. But as a data scientist, you also need to know this knowledge, know this part as well. Then you see the modeling part on the left side. Whenever you have your data, whenever you collect your data, put it in your data storage, made a pipeline to read the data, clean the data, store it again, and then make another pipeline to read the data, and then you model the data based on the question you have. The question comes from business understanding. So in the modeling part, you need to select the features you want. The features can be basically numbers or text, image, videos, whatever. So which features are important to be considered in your model. So this is a very important part of the data science also, that the feature engineering, feature selection, also call it, that you select, that you think that these features I need to have in my model to answer the questions that I have in the business part. And then whenever you understand that the features you want to use, you start modeling your, training your model. And here, yeah, there is a huge ocean of lots of algorithms. Yeah, in machine learning, there are supervised learning, unsupervised learning, reinforcement learning, deep learning. You have neural network, a lot. So here also you train your model. And this model, if you see in Python or R, maybe there are 3 or 4 lines of code. Basically, garbage in, garbage out. So you need to be very careful that what you import to this model. That's why the feature engineering is important in that part. So when you train your model, later you need to evaluate your model. For evaluation of model, there are a lot of knowledge you need about cross-validation, model reporting, A/B testing, grid search, hyperparameter tuning, all those knowledge you need. There are a lot of different parts in machine learning or deep learning that you need to know. And then later, after you did all things for business understanding, modeling, and data acquisition, you want to deploy what you built so far. Deployment means that you want to deliver something to the customer, and where you want to deliver it and how you want to deliver it. You want to deliver it as a dashboard, you want to make a website, you want to make an application, an app, whatever. And this is part of the based on the, let's say, end user request. And it is very important that you have very good understanding of your end user and create something that the end user wants to use. And then you basically give the whole thing to the customer, and this is the end. So you see that there is a big difference between this slide and the previous slide. The previous slide, I said that everything is very simple. Yeah, you are a data scientist already, you solve problem with data. The old lady in that city is a data scientist. But here you see huge amount of knowledge you need to be a data scientist. To make it easy for you, I will explain that how you basically need to do all of these by steps. One thing I want to mention before going to the next slide, that I forgot to mention, that look at these two-sided arrows. So it's not always that you start from business understanding, going to data and modeling. You always need to go back to the data when you are modeling. You always need to maybe go back to the business when you are modeling, or also deployment, you need to maybe go back to your data. It is always going forward and backward. So it's not a very direct way to look at this. Let's back to the steps that I want to explain to you, that you need to take care of these 4 steps to do a data science project. Before I explain it, I guarantee that any of you, if you follow these 4 steps, you will have a very successful data science project, and the stakeholders saying, yeah, well done, good job. We are very happy with your project. So these are the 4 steps, and you need to go step by step and be patient on each step. You can see that these 4 steps on the x-axis, the difficulty increase, but also the value also increase. So when you go for the next step, it's getting more difficult, it's getting more complex, but of course you will receive the higher value and higher price for what you do. Very briefly, shortly, I explained this graph, but I'm going to explain it by example in the next slides. The first step is descriptive analytics. So basically, you have a data, you have a question, and you want to know what happened. So the simple question that I have, that all of you now understand, that how many people got infected by COVID-19 in different countries? That's a very basic question. And you can solve this question, answer this question with very simple visualization. You can show with graphs, plots, tables, whatever, you show it. And then you basically finish this step. Very interesting part for myself, which is because I like visualizing because of my background in statistics. I like to visualize things. That's I like this part very much. Then whenever you understand what happened, it's the next question is, why did it happen? So you understand the situation, you understand that people get infected, but you see that many people are passed away or died in some location, in some other location people are survived. And this is the why question. Then you need to diagnostics. So that's why it's the diagnostics analytics. Then you dig into the problem after answering that what happened. You see that why this is happening and answer this part. And the next step is, yes, after you understand what happened and why did it happen, so you have a very good image about the situation. And you see the pattern, you see some relationship, and then after that you can go for the next step, which is what will happen. And this is a kind of predictive analytics. So you predict what's going to happen. So how many people, the question can be, how many people will be infected by COVID-19 in different countries? You can answer these questions because you did the previous 2 steps. You did analytics about what happened. You understand why this has happened. So you have a pattern, you have some clues that you can use them to answer the prediction questions. Then the last part, which it is very important actually, part that is called it prescriptive analytics. And how the question is, how can we make it happen? Basically, this part is a lot about the end user, about the let's say institutes, about the stakeholders that provided the questions to you. And then they want to know that how we can, for example, the question is, how can the number of deaths be reduced? So this is a really end user question. This is a really decision maker question. And it is possible to answer this question only if and only that you did the previous 3 steps. And I will explain this step in the slides later. This is a very important part also to have a project that satisfy you yourself as a data scientist, that you do a project. Let's say that we have a use case question that it's asking us that discover the spreading pattern of infectious disease such as influenza. So they want to know that how this influenza spread around the country or around the area. And the another question is, how many incidences will observe in certain location in future. So it's a kind of prediction question. And yeah, this is, I can call it a data science project because there is a problem and we need data. And after we have data, we can solve this question and solve this problem with the data. So the first thing that I need is look around for the data. I found a data for flu, for influenza, in the website of WHO, World Health Organization. I really suggest you later you go and Google for this data set. It's a very nice data set. You can simply download it and do a project by yourself, basically some explanatory analytics data, so data analytics. So it's a very good website. Please check it later. So here, remember based on the explanation I did for the big graph I had at the first time. So here I have a website, WHO. There is a data set. I make a pipeline. I make an API to collect the data and store it in my, let's say, server or my laptop or whatever, or cloud. And then this is what I have. Then I clean the data and I make the data ready for the next step, which is the analytics, basically, and answer the question, what happened? So what happened about the influenza in my location? Then to answer this question, that what happened, the best, I said it before, I say it again, the best and the wonderful way is visualization about it, for this visualization about the situation. So you have an area, you have a locations, you have your states, province, municipalities, and you know that how many people got sick in a certain location in a certain time. So you see the time, you see the date, you see the number of people got infected, and you also can, on the right top, you can see that how many people got infected in total in the whole region. And then you see that when the number of cases are increasing, which location are mostly heated by influenza and which location are less heated. For example, you see that now the number of cases are increasing. So I see them in the middle of my province, and the south, there are more cases than north. So north is more or less is isolated. So there are few cases there, but when the number of are getting high, I see a lot of cases down, and in some municipalities or cities, there are a lot of cases. So the visualization is showing me a lot. Visualization tells me, kind of giving me some clue about how this influenza spread in that city and in that area. Also, if I use, for example, the age of the people who got infected and then plot the distribution of the number of people who got infected over the time, which is on x-axis, in different age group, which is in y-axis here, you see 0 to 10, 10 to 20, and so on. I see that, yeah, maybe it tells me that 4 years back there were more young people that recently. So 4 years back, more people got sick. They were younger, and then now recently there are more old people get sick. So this is very nice. You see the point. You see that with very nice visualization, you select your visualization with a very nice visualization, you get very nice clue to answer the first question, that what happened. And this is the beginning, but for me, as I said, it's very interesting part of the data science project, because I'm curious. I like to plot everything and then find the interesting part in my data. So you see that with visualization, you can answer the question, what happened? It is not have to be, it has to be a graphs or whatever. It's can be also a table, very simple one, but it's up to you. It's up to the project. It's up to you. But find the first step, find the answer for the question, what happened in the data set. And then whenever I answer the what happened, I'm curious about why did it happen? For example, why 4 years back young people got sick, but now recently old people got sick? Why in one city or one country there are more cases, and why there are in the next city or next country there are few cases? So by those visualization, by doing the first step, you have wise questions. So the why this is happening. At this point, you need to do some domain study. So for this project, for example, I did a lot of studying about influenza itself. So the flu, the virus, what is the virus of influenza, how it's spread, how it's moving from a person to another person, what is the incubation time. So a lot of knowledge that is not basically in my background. I watch a lot of YouTube videos. I talk with domain experts. This part you need to do some domain analytic, domain studying. And after doing that, I realized that, okay, this is this is a virus and it spread from a person to another person. When I showed this 1.5 years back to some of in the project that I was there, people were not really understanding, or they're not feeling that. But now we are all seeing that because of the COVID-19, we can all understand it, that, okay, the virus spread from one person to another person. Yeah, sorry. And this, if this virus, which is spreading from one person to another person, it moves among us. And after its move, you see that this is happening in the corona, that they say, okay, don't touch, don't be close to each other, don't gather together, because the virus behavior is like that. At this point, when I did this research about the virus, I realized that how can I track? Remember, the question was, how can I track the spreading of the virus? How can I find the pattern of the virus? When I saw this, when I was thinking about the question, when I did some research about the the virus itself, I realized that if somehow, if I track the virus, I can find a relationship between the people. Who is living with who is working with who in the same office, who is studying in the same university, who gathered with who for a party, or so on. So I would say this is the main idea that came in my mind to go for the modeling and prediction and understanding what did it happen. It came only and only that I did the first step, that what happened, and then I studied about the virus. So a lot of people talking about, yeah, being creative, you need to do brainstorming, being creative, having creativity ideas. Those comes to your mind if you are really into the problem, if you are studying the problem, if you talk with the data expert, if you talk to domain expert. So I'm not a creative person. It came to my mind, this idea, because I was studying that, right? I was into that. So the idea was, if I track the virus, I can find a relationship between the people. then I can answer the question, why did it happen? So the question here, for example, is why Netherlands, for example, get influenza. So I said that, for example, in January, here in January, there were some countries with the number of cases for influenza, and then the situation, the number of cases for influenza in January had impact on the situation for Netherlands in February. This came in my mind based on the relationship between people. Yes, I see that the people have relationship, that they got sick from each other. So I want to find those relationships between the countries to answer the question, why did it happen? So I was curious about the pattern, relationship, association between Netherlands and other country in the Europe. So I made an assumption that whatever happened in January had impact on on Netherlands in February. So the viruses that were in January in other countries moved to Netherlands in February. This is also as an assumption, as it is as assumption. Sorry. So and then again, whatever happened in February in the Europe for countries has impact on in March in Netherlands and in April and so on. So by doing that, I kind of find a relationship between Netherlands and other countries. I see the impact of the countries on Netherlands. I see the pattern over the time based on the situation of other countries. So whatever you want to call it. So I'm saying that in different sentences: pattern, relationship, association. I don't want to, I'm doing that, I don't want to show you technical things in details, nothing. I'm not gonna dig into what I did exactly and why did I did. But I want you to focus on what I'm saying from the high level, very general level. I wanted to answer why did it happen? Why Netherlands got sick? So I made an assumption that Netherlands has under influence of other countries. And I made that influence over the time, and I call it relationship or spreading pattern, or the influence of other countries on Netherlands. What I have here at the end, I have a pattern, and I can call it, and I can answer that, okay, why did it happen? Because there is this pattern. There is a relationship between Netherlands and other countries around. So whatever happened in Germany, it will happen next month in this shape in Netherlands. It comes from the pattern that I can find here. And basically I answer what it happened. When I reach this point, it's very easy to go to the next step because I know what happened. I found the pattern that answer me why did it happen. And you all can agree with me that when I have a pattern, I simply can answer the question mark that what will happen. This is a prediction. I'm not explaining what model I used. You can look at this problem as an unsupervised learning, machine learning. You can look at it as a supervised learning, machine learning. You can use deep learning, neural network, whatever you want. I'm not talking about the model, but we have a pattern. We have a data that shows me a relationship between Netherlands and other countries. And then using this pattern using different algorithms, training models and evaluating. These two steps that was in the one of the graph at the beginning. Here it comes. So you can try all the algorithms you know, and then see which model is the best. And then based on the cross-validation evaluation you do, you say, okay, this is the best model I have. And then you have a prediction for Netherlands. And then you say, yeah, in next month, because in next month we have 100 cases for influenza in Netherlands. Why? Because the pattern shows me that whenever I have 10 cases in Belgium, 90 cases in Germany, 100 cases in England, so on, I have 100 cases in Netherlands, right? So this is what you, this is actually the third step. Here, it's also a very interesting part that, remember the two-sided arrows that I showed in the graph. Now you build your model, but still you can go back and check your data. You made a pipeline, you made an API to collect data from the WHO website, right? But still you can enrich your data. At this point, at this point, you can use other source of data, for example, weather. We all know that the weather has very high influence on influenza. The flight, the bus, train transportation. Demographical information of these countries also is important. Which country is old, which country is a young country. And these all have impact on the influenza. So you can enrich your data again, and then come back to your modeling, and then again, train your model with the new different, all of these different data sources in different algorithms. You train them, and then you evaluate it, and then you find a model. That's why that here you see that wide it was a two-side arrows, that you always maybe can go back and come back to your modeling and use the new source of data to enrich your database, and then improve the value of your model and the output of your model. Then you go to the last step. How can we make it happen, right? This part is I decided to use another graph, which is the same one, but showing in a very different way. You see that they are circle and they are inside each other. And in fact, it is like something like this. So whenever you do, you cannot do diagnostic without doing descriptive. You cannot do predictive without doing diagnostic. And after you did all the effort you do, this is this slide is important for you guys, that you as a data scientist, at the end, whatever you do, whatever you work on, all the efforts you do for the descriptive, diagnostic, predictive part, you put a lot of effort, time, energy. At the end, you will be happy if someone uses it. If you are not preparing something that nobody using that, and they say, okay, yeah, very nice visualization, very good prediction, very accurate prediction, okay, good luck, bye-bye. You feel good, you will satisfy if someone use it, you see someone use it, right? So this part is very important, and you need to take care of yourself here. And how? You need to understand the end user. You need to be very good connected to the end user and deliver your work in the best manner based on the end user needs, right? It can be anything. It can be a dashboard. It can be an automatic report generator, any tool, decision-making support tool, recommendation system tool, whatever it is, it should be something that the end user wanted and use it. For one of my project, this is my experience, and I'm sharing with you that for one of the project I did, I created a very nice dashboard, and I presented to the end user, and they said, well, very nice, very beautiful. Yeah, but it's hard for us to open it. It's hard for us to run it, and yeah, we cannot check it all the time. So yeah, thank you, right? Then I said, yeah, I walked around the organization and I saw that, yeah, there are not really people who like to use tools, dashboards on app. They are people who are using emails. Yeah, they send emails and they do everything in Outlook. Emails, they basically work in Outlook. Then I was thinking, okay, you are not using dashboard. I transferred the dashboard to a report that whenever the code actually basically every week run, and then the output is a Word file as a report, and the tools send it the report, the Word file, automatically to their email. So basically they receive the output but in their email. So yeah, they don't need to open the dashboard, they don't need to put a lot of effort. They are working in Outlook, they are working by emails, that they receive by email. Now they are using that, they are seeing the result of my prediction, and I'm happy because a lot of effort I put to make the prediction model from descriptive, diagnostic, and predictive, and I was very frustrated that seeing that they're not going to use it. So I was thinking that how can I change it that they use it? Because of myself first, because it was important for me that they use what I did, right? But of course, in the general projects, you also need to talk with your end user, the stakeholder, and deliver what they want. Here you need to be very flexible. Here you need to have a lot of knowledge. Maybe they said we want an app, we want a dashboard, or we want a report. You need to maybe study to learn this programming language, that programming language. Yes, you need to be flexible. But whatever you do here at the last step of your data science project, whatever you do, it really depends on this last step. So this last step, I explained a lot about it because it's important. And at the end, whatever you did, people see it in this step. Otherwise, they're not seeing that. There are a lot of models with high accuracy, but yeah, nobody using that or nobody seeing that. So I would in this slide, I would finish what I had today for you. I try to explain what is data science, very basic and general point of view, and explain who is data scientist. Yeah, and based on my understanding, yeah, all of us are data scientists because we are happy to solve the problem with data. That's enough for me, data science. But of course, in the real world, you need to have a lot of knowledge. You need to have different knowledge in programming or maybe in the mathematics or statistics. But if you follow those steps, if you learn in each project the techniques you have to learn in each steps, and you follow those steps that I explained for doing a data science project, you will be very successful. So I hope you enjoy it. I hope it was useful for you. Thank you very much for joining this session. Thanks FruitPunch AI and also Jets, and special thanks for Wedad for giving me this opportunity to talk with you guys. I'm open for any questions you have. Please unmute yourself, ask me a question, or drop your question in the chat part, but I prefer to hear your voice if you can. Yeah, thank you very much.
Thank you, Mahdi, for this fruitful talk. I think it had many details. Mariam had a question on the chat, but Mariam, can you unmute yourself and ask that question?
Hello.
Hello.
Thank you so much, Mahdi, for the presentation. It was an amazing presentation. I think. And I just had a question. If you can please talk briefly about the model you used to predict influenza pattern in the Netherlands. You said that you don't want to go into the details of the model, but I was a little bit curious to know the model that you used and how did you structure that model? If you can talk briefly about it, no need to go into the details.
Yeah.
Thank you so much.
No problem. Basically, I've calculated the pattern, right? So I said that I would like to ask you to imagine a table, a data set table. And I have, for columns, I have the country name. And for the last column, I have a Netherlands. So for each country, imagine I have, for each row, I have the number of cases happened in January. And for Netherlands, which is the last column, I have the number of cases for Netherlands in February. And then in this row, you see that I have a X variables and I have a Y variable. So basically, this is the part of that was tricky part, that I transferred this pattern over the time and made my data frame to use the supervised learning, machine learning. So I have variables and I have a y-axis, which is the output, which is the label. Let's say in machine learning, they call it label, right? So this is, I call it pattern. So how I had 400 rows. January to February has impact. Then next row, February to March, and then so on. Then for this table, I hope that you could imagine this table that I explained. I have variables and I have a label. I applied several models for that, decision tree, supervised learning, machine learning algorithms I used. Decision tree, random forest, Poisson regression, normal regression, I'm saying that, linear regression, normal regression. So then I did the evaluation for each model, cross-validation I used. And then I found that, okay, the best prediction I can get is the random forest one. The tricky part, I explain it again. The tricky part is that for the answering the question, why did it happen? And I calculated those patterns. I thought that how can I transfer those patterns to a data frame that I can use it for a machine learning algorithm, right? This was the tricky part. And then, yeah, then later you can apply any machine learning algorithm, which I did, and then I end up with the random forest. I think, I hope that you got you the answer of your question. If it is not clear yet, please ask me. Yeah, it's clear, I think. Oh, no, thanks a lot. Oh, it means it's clear, right? So it's no thanks a lot means you didn't get your answer, but thank you, right?
No, I got your point.
Okay, go on. Okay, yeah, thanks for your question. Yeah.
Thank you.
Yeah. If anyone else has a question, please. Then I guess nobody. Maybe it was very clear. I don't know.
Okay, you have a question. Hassan, or Hassan, I'm not sure. Can you unmute yourself? Otherwise, I will say the question.
Okay, okay.
Okay, so
Hello?
the question was, okay.
Hi, thank you so much for the presentation. Just wanted to know, do you have any advice for the types of projects to work on as a beginner?
Well, that's a very good question, because I prefer to learn data science, but by doing the project. So I prefer that I get the data and get a question and I start doing that. And then meanwhile, if I need something to learn, and I go learn it. So I do not agree to sit in a library and study data science. I do not understand this, right? So thank you for your question. This is a very good question. And please learn data science. You said as a beginner, learn data science by doing that. So for example, internet is full of data sets and full of questions. For example, this influenza data I showed you. So you can go and download the data for Lebanon or Middle East or your area, and then start visualizing that. Then you learn visualization by real data. Then yeah, you can make a map of the Lebanon or countries around the world, or Asia or Middle East, whatever you want. Then then you learn visualization. Then you answer the question that okay, how the influenza spread in that area, what's different between countries. So the data is everywhere, but it's also up to you as a data scientist that define a good question. Maybe sometimes you have a question by a stakeholders, but sometimes you yourself need to define your question. So I maybe later I can make a list of the data sources in internet, but you can just need to copy Google it, that okay, data open data, right? And then you find it. But to make it interesting for yourself as a beginning, I suggest you to do 3 steps. First of all, find the data that you like in a domain that you like, right? So maybe I'm interested in healthcare, so I prefer to, if I want to spend time, I go and download the data and find data in healthcare. So go find the data you want. Second, start making a question you want to answer with that data, right? So I myself was very into infectious diseases. I myself really into the cancer area. So I try to make a question for myself based on that data to answer. So if you, these 2 steps, I'm saying that all these 3 steps actually, that I'm saying that encourage you to do it. So if you do something that, yeah, you can go to Kaggle, there are a lot of challenges there, but if you are not really into doing that, if you are not motivated to do that, you, at the meantime, you will give up. That's why I'm saying that try to do everything around yourself. The data you like, the domain you like, the question that you like to define, and then answer those questions. And the further step, that publish the results you have in LinkedIn, in GitHub, in Medium, whatever. Start creating your portfolio. Start creating what you have as a result, and share it with people and get feedback. It's also encourage you. You see the feedback. Most of the feedback are good. Some of the feedback maybe are not good, and then you need to improve. So please do these 3 things if you are a beginner in data science and you want to do it, and you don't want to rely on anyone, you want to do it by your own. These 3 things are the key points. You please do it like that. And you ask in the text, I see that you ask for the specific types of the projects. I said no, types that you want. In all the types around the world, all the domains around the world have problem, and you can solve their problem with data. What do you want to do? This is, you sit and ask yourself and do it by yourself. You're welcome. Now I see, yeah. Any other question? Raouf Haji said, great presentation. Thanks all. Thank you for being here. Now I'm seeing this chat part. No question. I guess there is no question. Yeah, and then with that, maybe we can wrap up and finish it.
Yep. Thank you for attending. And if you have any more questions, you can send me an email and I will send it to Mahdi. And also we will send you the slides of this presentation with the recording.
Yeah. Yeah, I would be happy if you want also to make a contact in LinkedIn. Yeah, it's okay, please.
Mm-hmm.
Yeah. Thank you very much, guys. Have a nice weekend or days, whatever. Yeah. Bye-bye.